Welcome to the Invention Coach, an adaptive computer-based environment that guides students as they invent their own equations for physical science phenomena. The goal of the Invention Coach is to engage students deeply with exploratory problems, which can prepare them to learn from a later explanation of the solution and the key concepts underpinning it. This is one invention task called the Crowded Clowns task. Here, students see 3 companies that use buses to transport clowns to parties. Some buses are more crowded than others. Being on a crowded bus makes the clowns very grumpy. So to determine which company is best to order from, students are given the goal of creating a clown crowdedness index. An index is a number that describes how crowded the clowns are in each bus. There are a few rules. The index number should be exact. The same method should be used to find the index for all buses. A bigger index means the bus is more crowded. And finally, buses from the same company should have the same index. In addition to opening the rules, there are other tools students can use. They can type in the notepad, use the calculator, or hit the help button if they get stuck. Invention tasks are highly iterative. Students can submit their solution to get feedback from the coach avatar, then change or refine their solution. The feedback is adaptive. Depending on the type of solution the student enters, the Invention Coach responds with tailored feedback. Sometimes the coach provides basic reminders about task constraints such as this one. And sometimes students are asked to complete short activities with carefully designed problematizing guidance. Unlike other types of guidance that simplify the task, problematizing guidance increases task complexity in the short term, but it encourages students to wrestle with key ideas they may have overlooked and to recognize aspects of their thinking that are problematic. A common solution students initially try is to simply count the number of clowns in each bus. This is a good first attempt, but it ignores the size of the bus the clowns are in. In this case, the student submitted a counting solution, and the coach responds with a contrasting examples activity. For example, here students are asked to contrast the blue and green buses, choose which is more crowded, and explain why. By contrasting example buses, students should notice that the size of the bus is important, and so is the number of clowns. But incorporating both features into an index is not easy. The ranking activity taps into students' intuitive understanding of crowdedness by asking them to rank companies from most to least crowded. This helps students notice which company should have a high index and which should have a low index. A student might then submit an estimating solution where buses are simply ranked from most to least crowded. The Tell Me How activity prompts students to explain their solution method. This encourages them to reflect on their method and points out problems with their solution. As students' solution methods evolve, they often begin to use mathematical operations to calculate the index. In the Tell Me How activity, students must show their calculations and label each number. This encourages precision in students' thinking. Of course, the correct way to calculate the crowdedness index is to divide the number of clowns in a bus by the number of cars in the bus. And most students will have to wait until the lecture to learn this. But that's okay, because by grappling with the task and the coach's problematizing guidance, students are now better prepared to learn about the related concept of density and other ratio-based equations in science.